All right, good afternoon, everybody. Going to get started on time because we've only got a 30-minute block, and I'm notorious for running long on my presentations or talking really fast. So if I'm talking a little too fast, please let me know. Today we're going to talk about Hortonworks DataFlow, primarily, or more specifically, the Apache NiFi component of Hortonworks DataFlow, and how you can enable real-time insights to derive actionable intelligence. So my name is Michael Young. I'm a senior solutions engineer at Hortonworks. I've been at Hortonworks for 2 years. Prior to that, I spent 13 years as a consultant slash contractor in the intelligence community for a number of different agencies there. So we're going to talk a little bit about Hortonworks just because that's my employer, and we are the primary commercial sponsor around Hortonworks DataFlow. Promise it's only one slide. Then we're going to get into the meat of it, which is flow processing with HDF. And of course, I like to focus more on the demo than just slideware. So Hortonworks, we were founded in 2011 from the original 24 Hadoop architects that came out of Yahoo. Our motto for the longest time was Hortonworks, we do Hadoop. How many of you have heard of Hortonworks before? Show hands. All right, so that's good. How many of you have heard of Hadoop? Okay. And Hortonworks DataFlow? What about NiFi? Okay, good. So Apache NiFi is a core component of Hortonworks DataFlow. So what I'm going to demo to you is just the vanilla Apache NiFi that you can download. My demo is actually running on Docker containers, so super easy to spin up. So as I was saying, we were founded in 2011. We have a little over 1,200 employees and 2,300 partners in our ecosystem. We are the primary commercial sponsor around Hortonworks DataFlow. Apache NiFi was spun off as a top-level Apache project in 2015. The core original developers of NiFi came out of the NSA, where it was originally developed. It was formerly known Niagara Files. You guys may have heard that term used in the past. When Anyara spun out of, or when the group spun out and created Anyara in 2015, Hortonworks acquired them, and therefore all of the meat in terms of subject matter expertise around the platform. We do offer product support, so we're subscription support. We don't, our products are 100% free and open source. We don't actually sell you a license. We sell you our expertise. So along with that comes professional services and training. All right, so HDF 3.1 is the most recent release of Hortonworks DataFlow. There are three major components to this. What we're going to be talking about today is flow management, and that's primarily driven by Apache NiFi. There are some other aspects to it, stream processing, and streaming analytics, so that's where Kafka and Storm come into play. We have customers that deploy HDF using all of the components, and we have customers that deploy HDF using just the flow management or just the streaming analytics portion. We have customers who are, use their NiFi or HDF to primarily push data to Hadoop, but we probably have just as many customers who have no Hadoop presence whatsoever in their enterprise, right? So that's one of the nice things about HDF is that you can use it to connect many sources to many other sources in destinations with filtering and transformation in the middle. So there are two major components to the flow management. One is NiFi, the other is MiNiFi. MiNiFi is a lightweight agent. We offer it in C++ and Java. What that's really designed to do is get you out to the edge. We view real-time data as perishable insights, right? So you want to try to take actionable you want to be able to take action on intelligence as close to the edge as you can, because as that data becomes stale, it becomes less and less valuable. So what C++ and the Java agents are designed to do is make it really easy to push that out to the edge where you have more stringent compute, processing, memory, storage, power, and cooling. So what is data flow management? So NiFi is often used, people say, oh, well, is it in Informatica, right? NiFi certainly can be used to do transformations. It could be used to do, extracting from a database and throwing it, into Hadoop. It can be used to do some, fairly basic change data capture, right? But its primary focus is all about helping you visualize and control the flow of data from multiple sources, one or more sources to one or more destinations. So when you're looking at your data flow management, the question is, well, what are my sources? Like, where's the data coming from? What's the structure of the data? Most organizations tend to have, a variety of data formats. It's not just JSON, it's not just CSV or Apache logs. There are IDS logs, there are, router logs, there are unique application logs where people, often, write their applications. They don't necessarily use Log4j. They might write, custom logging. where are you going to write that data? Are you writing it to the Hadoop cluster so you can do predictive analytics? Are you writing it to a file store somewhere? Are you pushing it out to S3 for archival storage, or Glacier for that matter? And then there's the aspect of batch versus real time. And we have customers that use NiFi for both. So you can do bulk pull of data periodically once every 24 hours, or you can actually stream data in real time. You can have a flow that does both. That's the power of NiFi, is that you have the ability to easily create flows where you can mix and match your use cases in terms of batch and real time. And then there's just the standard processing that you want to accomplish while you're pulling that data in. Most organizations are looking to do quite a bit of standardization in terms of normalizing data, standardizing the field names, normalizing the date, for instance. When I spent quite a bit of time at the FBI as a consultant. We've had tons of data sources, and no two were alike. Every data source was a unique snowflake, and it was not uncommon for us to have a data source that was well vetted, well established, used on a regular basis, and then from one load to the next, the schema would change, right? With no notification, right? We didn't get a DTD that said, oh, hey, by the way, here's the changes in the schema. Things just broke on load. So being able to have a system that can react to schema changes and intelligently send emails or SMS messages is pretty powerful. Trying to understand, how much time do you need to process the data? NiFi gives you the ability to control whether you want throughput or you want latency, and you can do that on a per processor basis, right? So depending on the source, you can adjust them. So one source has more throughput, another has more latency. Like I said, when I was in the one project that I worked, we had 53 different data sources, right? And you had different teams that were working, respective sets of data sources. And then we used a variety of tools, and it was often painful. So if you wanted to find out how one data set was processed, you had to go to one team. Another group of data sets was another team, and they probably used a different set of tools. We had Python, we had Bash plus SQL, we had SQL Loader for Oracle, we had Pentaho PDI, we had Informatica. There was really no one consistent approach, which meant that there was a huge learning curve, and just trying to get people onboarded in the event that someone decided to leave the project or you need to expand was fairly arduous for us. So, another thing to consider when you're looking about your data flow is, what kind of data are you working with? As I said, we had structured data, we had unstructured data, we had semi-structured data, CSVs, JSON, stuff coming right out of Oracle. So being able to have one tool that easily handles all of that seamlessly and not really caring what the data format is incredibly enabling. Being able to look at user-generated content, that's notorious for being dirty data. For instance, you go out, and I'm going to actually demo on Twitter data today. But the Twitter API, you can actually get tweets that have no text because those are deletes. They're not necessarily tagged as deletes. They're easily identifiable. So you're going out there and just say, hey, give me all the data. Well, you'll find that you're getting a bunch of empty tweets. And you're like, well, why are these tweets empty? So being able to filter on that data so that you can say, well, you know what, I don't want to handle anything where the text of a tweet is empty, right? You can choose to just drop those records, or you could choose to route them and do something more intelligent. We have customers that are pulling data off of oil rigs and cars, being able to make real-time predictions of data, so collecting all of the sensor data off of a vehicle and correlating that with GPS information to be able to say, you are in an area at the time of day where there is known high pedestrian traffic and a higher risk of auto accidents, and sending a notification to the car to slow down, reduce speed, because if it's a high congestion intersection you're getting ready to go through. These are some of the things that the city of Las Vegas, for example, is experimenting with in terms of connected cars. So I was talking about which tools do you use. I think this right here. How many of you are sort of familiar with the idea that you've got more than one tool managing your data? By show of hands, right? Is it more than one tool? Is there ever just one single tool that you're using? Right, exactly. And sort of the nature of open source, in fact, right? It's like, oh, well, we've got 14 different ways to do it. We need one way to do it. And that inevitably turns into just 15 ways of doing it, and then it becomes 16. Instead of taking an existing project that works well and maybe tweaking it to meet your needs, it's like, no, I'm going to fork it and I'm going to create my own version that's subtly different because that's what I want to do. It's empowering, but at the same time, it can be a little frustrating when you're just trying to get your job done. So Apache NiFi, right? So this is a screenshot of the UI, but I'm actually going to show you the UI in real time. But it's a web-based user interface. You're not installing a thick client to actually use it in terms of the end user interface. It serves three personas. The first persona that it serves is the actual data architect, the DataFlow manager, the person constructing the flow and managing the data from end to end. The second persona that it serves is operations. There's a graphical command and control interface that you can interact with the flow in real time. This is important. Not all data flow managers are necessarily responsible for managing the operations of the flow. Is it achieving the throughput needs that it needs to? Are there errors, right? Being able to, in the UI, clearly see if I've got back pressure on a particular component also helps me do root cause analysis. How many of you have seen performance issues related to either storage or networking or the database, and when you go and you raise the issue and you say, hey, I need help, there's something slow here, everyone just kind of goes like this and says it's not my problem. I mean, I've run into that myself. Oh, it's the database. No, it's networking. No, it's the SAN. It's pretty frustrating. With the visual UI of NiFi, you can see via the processor where your back pressure is starting to hit. So if the database is slow to ingest those records, you can say, no, clearly, this is all the other flows are moving along just fine. Everything is running as expected in nominal capacity, except the point where it's writing to the database, or where it's writing to the SAN storage or the NFS storage. So what NiFi is giving you, they get guaranteed delivery. There's a ton of capabilities here that allow you to get, yes?
Who's that third persona you mentioned?
Oh, I'm sorry, security, right? So I was going to talk about that here in data provenance, but the guaranteed delivery, it's all about the data flow manager and operations, right? The data buffering, back pressure, being able to actually see where you're seeing. So if you have an intermittent connection, right? So in the case of the connected car that I talked about, you have a vehicle choosing a cellular connection. Cell signal's not always available. It's not always strong. What will happen is NiFi will create a backlog queue of your data so that when the cell connection reestablishes, it just picks up where it leaves off, to include being able to prioritize, that back pressure release. Data provenance is for the third persona. This is security, right? Being able to see for every step of the flow, for each piece of data that gets routed through that flow, what happened to it. You can actually look at the data before and after each of the processors in the flow. So I actually used this. I was playing with Twitter data, and I wanted to add a new field to the Twitter data, right? And somewhere along my flow, I'd updated the JSON. I added a new field just so that I could, route it appropriately. And other processors in my flow were throwing, JSON parsing errors. And I'm like, well, wait a minute. I mean, it works elsewhere. And so being able to look before and after, I could see what the JSON looked like before the processor that, I configured to edit the JSON, and what it looked like afterwards. And I said, oh yeah, I fat-fingered that. Did not have a closing bracket. Clearly, I messed up there. So being able to sort of iteratively look at the data as it's flowing through is pretty empowering. So that's useful from a data flow management perspective, but from a data provenance perspective, when your data stewards and your security people say, I want to know what this piece of data, right? I've got a record here. Can you tell me what happened to this record? NiFi supports pushing to Apache Atlas, which is our data governance tool. So what it allows you to do is tag your data. So you can easily apply data governance tags. This is PII, this is PCI, this is HL7 communicated data, it's HIPAA data, right? You easily have the ability to create these tags, and NiFi can send all of the provenance data over to Atlas, which allows you to have a sort of a central tool for doing a data catalog, right, for your infrastructure. Again, being able to have push and pull, right? So we have more than 220 processors, which I'll show you in a slide or two here. But having that number of processors means that you have the ability to connect to MongoDB, Cassandra, Hadoop, Oracle, MySQL, Postgres, SFTP servers. You can make RESTful web calls. I've written some flows where I go out to the FDA website and I'm pulling down XML messages from the FDA website and then parsing that XML and then throwing that in the Hive so that I can then run BI queries, right? Or you could throw that into Oracle and then have Tableau going against Hive and or Oracle. So as I was saying, HDF 3.0 has 220 plus processors. So what that really means, it shows you the pace of innovation from HDF 2.0. It shows you the extensibility of NiFi. It's incredibly easy to create a processor. I was talking to a Department of the Army prospect, and they were like, "Yeah, I'm new to NiFi. I've heard about it. I downloaded the example, the example processor, and I built my own processor, in 4 hours." I was like, "Oh wow, that's pretty cool." So it shows you how easy it is to take the existing documentation, the existing samples, and so if there's a processor out there that does something similar to what you want, but perhaps not exactly what you want, you can extend it, or you can write your own. And so you can have the built-in processors, or you can have custom processors. You also have the ability to control which processor is available on the system by removing them. They're packaged into what's called a NAR file, a NiFi archive file, which essentially is just a jar. So if you decide that you're in a controlled environment and you want to limit what processors are available to your DataFlow managers, you can remove those processors. So again, a ton of capability here in terms of pulling from and pushing to sources, doing extracts and transformations. So it's really popular for customers to be able to, in the latest HDF 3.1, the record reader and writer. So you actually have the ability to take data like CSV and JSON and convert that over into a record, which is now SQL accessible. So you can actually run SQL queries on data that's not technically SQL. Where that's powerful is in your flow, you can route, and your route can be based on, I want all records where some value is greater than 5 or 40, right? And you're doing that on data using standard SQL, but it's data that's CSV or JSON. Incredibly powerful. So, what are some things that you can do with NiFi, right? So again, you can connect all the very standard connectors. We have a lot of customers who are fond of Splunk, right? The problem is that Splunk tends to be pretty costly when you start throwing tons of data into it. So what they look for is, I want to intelligently route the data to Splunk so that I can route the data. I don't want to go to Splunk to go land in long-term storage or a Hadoop cluster, right, where I can hold years worth of data, and I only want to route particular data to Splunk. So there's a Splunk connector. Being able to pull syslog data off of servers, right? So you're looking at logging data, being able to read and write from email. Those are all the standard kinds of connectors that allow you to integrate with systems and feeds within your environment. Being able to do transformations. It's very common in NiFi flows to have data come in as JSON or CSV or HTTPD formatted logs, and then convert it to Avro, for instance. Avro is a really popular format for storing data on Hadoop. Being able to do compression and decompression, encryption, hashing. You can do all of that on data, in parallel. So you can actually have data split into multiple feeds, sent to multiple locations simultaneously. One location, it's all encrypted. Another location, it's compressed, and it's just a hash. So being able to route your data based on not just the content of the data, but the metadata as well. So you can route on content, and you can route on attribute. Does my data actually contain the value XYZ? If it does, do something with it. Does the data have a metadata attribute of, received from a particular server name? You can route on that. And obviously, as I said, you can parse XML. I've done XML, I've done JSON, regular expressions for those who have played with Python or Perl regular expressions, right? All of that is supported, and there's even support for some, grokking in some of these processors. So what does the NiFi architecture look like? Well, NiFi is Java, right? It's 100% Java. So what it does is it runs on a JVM on a host. So it's, you can spin up NiFi on a single machine. NiFi actually consists of 3 repositories: the flow file repository, which is all of the information about the flow itself, right? The pieces of information, the metadata about the pieces of information that are going through the system. The content repository is the actual data itself, right? And then the provenance is where all of that metadata about what processor changed, what piece of information, who started a processor, who stopped the processor, right? Did somebody replay a processor? Because that's another thing you can do is you can actually look at the data provenance and then replay a piece of information to go back through the system. So the scaling of NiFi is done by ensuring you have sufficient local storage for each one of these repositories based on your data throughput needs. So, calculating how much, capacity you need, it's pretty simple. You say, well, how many messages per second am I getting in a day? What's the average size of those messages? All right, I get, 300 megs a day. What is my worst case scenario for a data outage? 24 hours. Well, I need to be able to hold at least 300 megs of raw data, right? So it's really easy to extrapolate how much storage you need, and that's really what it's all about in terms of back pressure support, because everything's getting written to disk. To be clear, NiFi is not a data storage platform. The data is moving through NiFi. It's only being held long enough to be able to move it through the processors, and however long you've configured the system to hold on the data. The idea is that once it's moved through the system, it's gone, right? The data itself no longer exists. So you're not talking about petabytes of storage on a NiFi cluster. So a NiFi cluster has a primary flow, and that flow has 2 or more processors, right? Because you always have to have a beginning processor and end processor. Read from, write to. And then of course you can have multiple reads, multiple writes, multiple transformations in the middle. So the flow is shared across all nodes that you might put together into a cluster. All right. So one of the nice things about NiFi is you build it on a single machine, you build your flow, and you say, hey, this is working well. And then you say, I need more performance. I need to get more throughput. You add another machine to the cluster. Right. So then now you've got two machines running, and they're splitting the duties across that same flow. So unlike a Hadoop cluster where you can have thousands of machines in a cluster, NiFi is typically no more than 8 to 12 servers, right? So it certainly scales up pretty well, but the idea is that NiFi is intended to be used sort of regionally. So you have NiFi instances out on the edge, you have NiFis at regional data centers, and then they're chained together to push appropriate data up to the next level. So when we talk about the cluster that I was mentioning before, we have a zero master configuration. So we use Zookeeper. Zookeeper is pretty popular in the Hadoop ecosystem for managing state and configuration information. So what happens is the machines all join up, they talk to Zookeeper, and they will do a zero master configuration, and they will vote to see which server is going to be the coordinator and which server is going to be the quote-unquote primary node. So a coordinator node is responsible primarily for just checking heartbeats. Their job is to basically be the gatekeeper for which nodes are joining the NiFi cluster. That's it. The primary node is not a master per se. It is a node that's designated so that you can run a processor, and most processors have the option where there's a checkbox that says run on primary node only. Why would you want to do that? Perfect example is I got a bunch of data sitting out on an SFTP server. If I have that SFTP get processor running on 3 nodes, they're all 3 going to go pull the same list, and you're going to get 3 copies of the data, and you're going to get duplication. So what you would typically do is you would have that get processor run on one node, the primary node, and then the output of that processor would be a flow file, which is a list of files that you then pass off to the cluster, and then the cluster can then work on parallel that one list, right? So the primary node is where your run on primary node only processors run, and typically those are done for areas where you're trying to ensure just once types of semantics. So I mentioned the NiFi agents, the Java and the C++ agents. What exactly is that? It is a lighter weight version of NiFi. So you'll notice here that the framework, it doesn't have the UI. So that's the key takeaway, is that NiFi has no UI, right? It uses a YAML configuration file that you generate you use the NiFi UI today to generate a NiFi flow. You export that flow, and then you convert that flow file, which is by default it's XML. You convert it to YAML, and then NiFi loads that up. Right, so NiFi is meant to be run on those lightweight agents. You're not going to be logging into 1,000 IoT gateway nodes, right, looking at the UI. The idea is that you can push those files out, and it is hot loading. So what NiFi will do is when it sees that YAML flow file updated, it'll automatically reload it. So it makes it really easy for you to do some command and control where you can push out updated flows without having to log in to every machine and start and stop processors. The list of components is quite a bit smaller as well. Generally speaking, you're probably not going to use NiFi out on the edge to pull a bunch of data from a database, right? So things like database connectors aren't going to be included, by default, right? That doesn't mean that you can't drag those NAR files into your NiFi library if you want to, but the idea is to create it nice and small and lightweight so it can fit in those more constrained environment processing areas. So you'll notice this list here looks very similar to NiFi because functionally it is the same capabilities. You get back pressure, you get guaranteed delivery, prioritized queuing, you get the ability to control latency versus throughput. Why? Because the processors are the same NiFi processor, so the same configuration items exist. What's the difference? The difference is the design and deploy method, right? So you design it in a NiFi flow and you export it and deploy that exported template as opposed to using a UI. And as I said, it does have warm redeploys. So what does it look like when you kind of bring all of this together, right? So typically what you have is you got NiFi out on the edge, oil rigs, farm machinery, connected cars, buses, trains, subways and elevators for maintenance records. All of those things could be have data pulled from them via NiFi. And they're typically pushed to a NiFi cluster. And one of the first things that NiFi is going to do is it's going to push it to a Kafka cluster, because Kafka gives you a little bit more resiliency in terms of messaging throughput and in terms of other systems being able to consume that data, right? So yes, it's possible for a piece of software to talk to NiFi via a web API that you stand up in NiFi. There's a listen HTTP processor, so you can write your own sort of poor man's RESTful API, which is pretty cool. But the reality is there are a lot of tools that understand how to interact with Kafka, right? A message broker. So a typical best practice is the raw data comes out from the edge, lands into a regional data center, and then lands into NiFi, and then NiFi immediately pushes it to Kafka. That's just one of the passes. That's one of the paths. So the other processing could be done. Then it's going to do some, transformations. It's probably going to do some filtering, maybe some encryption, maybe adding some metadata, and then it's going to route it to other systems. So HDF as a whole, what we find is a very common deployment model is to use NiFi, Kafka, and Storm. That's why those three are bundled together. But as I said, we have customers who use just NiFi. And we have customers who use NiFi and Kafka without Storm. So if you have Spark, in fact, I've got a customer that uses Spark and Kafka together. They don't use Storm. So the idea is just to show you what's possible and what's a pretty common pattern. All right, so any question what I covered so far?
On that one, the slide what is told, we have a similar one instead of Storm and data break. Is there a way you can, the data flow, you can monitor that it is failing or it is delivered from source to string? NiFi will be able to, graphically we can see something like that.
So it depends on what the processor is, right, and how you're getting the data to NiFi. So pulling data from a database, I can easily see that there's a connection issue, right? And I can see the throughput of data coming through the system. There's also everything that you can do in the UI is backed by a RESTful API. So if the data isn't readily available in the UI, there's nothing stopping you from fetching that data from the API and sort of creating like a specific dashboard designed for monitoring it. I would say that most of the visibility really comes in within the middle of the flow itself. For the connectors that connect to specific source systems, it's really dependent on those source systems and what their capabilities are and how much effort gets put into exposing the performance metrics while we're trying to fetch it. All right, so let me show you here what this looks like in real time. All right. So what you see here, let me see if I can make this full screen and zoom in a little bit. So what you see here is a NiFi flow, and that's really, really washed out. At the top of the flow here, we have a get Twitter fire hose, and that really is just it's a processor designed to fetch from Twitter. So you have to have your own application key to be able to talk to Twitter. You can do things like put in your own filter for what terms you want to look at, right? If you want to look at particular users. So what we're doing is we're pulling the data in from Twitter at whatever randomness that Twitter decides to feed us. I'm certainly not paying for a full feed. This is just a random fire hose. Then the key attributes comes in. What's the text? What's the language? Who's the user? Has it been retweeted? What's the date, time? And then find only tweets. I had mentioned that Twitter likes to send out a tweet that has no text. That's actually a delete, right? So find only tweets is actually a filter. So what I'm doing is routing on attribute, and I'm saying if the tweet is not null, then go ahead and pass it. And what I'm doing is I'm pushing it to Solr, right, so that we can do searching and some dashboarding, and then I'm pushing it to the local file system. So you'll notice that the processor for Solr and these other ones are running, but this get Twitter is not. So if I hit start, you can start to see that some data is flowing through the system, and it's flowing through in real time. I'm going to keep that up and running. I'm going to switch over to my dashboard here. So this is just a banana dashboard. It's free, it's open source, it comes with Solr. This just shows you sort of the art of the possible, right? So what's happening is data is flowing from NiFi, from the Twitter API. I'm doing filtering. I'm extracting the language. I'm extracting the text, who the actual tweet is, right? And then that's getting routed to Solr, and now I've got a dashboard on that. It takes literally all of 5 minutes to set this up. I had reinstalled Docker on my laptop, and all of my original images were blown away, and I'm like, well, there went that demo. And wait a minute, I took notes. So it literally took me 5 minutes to run the commands to spin up the Docker containers. I've got 3 Solr containers running, 1 Zookeeper, and 1 NiFi container running. So just 5 really small images, and then we have real-time streaming feed here. I've actually had this data push at the same time out to S3. Again, I could push it to a database. I could push it to Hive. I could do more creative things. So we actually have an internal flow that we've managed at Hortonworks that we use for customer demos where we pull tweets from various law enforcement agencies and then categorize them and do some sentiment analysis on that. So what's a really popular thing is because NiFi is so extensible, you can write your own processor that actually sends data to a model that you've created. And that model could rate, do sentiment analysis on it. You can use NLP style processing. So those are all the sorts of the art of the possible, what you can do with NiFi. Any questions?
Do you have to set the rules for all these filters?
Yes, so NiFi doesn't come out of the box with any pre-configured rules or filters. It is very much what do you want to do with the data, right? So there are processors like route on attribute and route on content. If you say I have data where I want a tweet that has English as the language and I only want that, so you would route on content because that's actually part of the JSON, and you could say I want this to then be passed on to the next processor, and then you could have everything else get dropped or written to disk or sent over to another flow.
So it has the ability to translate in different languages?
So NiFi itself doesn't have any inherent ability to translate languages, but there's nothing stopping you. So if you actually go out to community.hortonworks.com, that's our what's known as Hortonworks Community Connection. It's a forum where people post questions, write articles. There are a lot of articles on NiFi, and they do things like NLP from Stanford, right? Using a processor that goes and, as I mentioned, that sentiment analysis. You could do some language translations using. Honestly, there's not a lot of great open source tools for language translations. You pretty much have to pay one of 2 or 3 commercial vendors. They do a pretty good job, but you're paying a pretty penny for that. Yes?
Is there any other implementation of NiFi like Cloudera does it? I didn't see Cloudera does NiFi.
No, so Cloudera does not use NiFi. NiFi is an Apache open source project. It is a top level project. It is completely free to go download. Cloudera has chose to partner with a product called StreamSets. There's some overlapping capabilities, but they are not one and the same product. So yeah, Cloudera doesn't use NiFi. Yeah, it's the same idea, but there's differences in terms of like security and governance and things like that. We're focused very heavily on security and governance as key aspects of the solution. At the granular level, being able to control who can access a flow. So you can create nested groups of processor groups within a flow, and I can grant you access to read a processor group. I can grant you access, the ability to start and stop a processor group, and I can grant you access to actually edit the group, right? All of that done via a nice UI. We actually use Apache Ranger for that. All right, thank you.